Hey everyone, today we're going to be talking about rearranging equations. When we rearrange equation, we are isolating a particular variable in the equation. Now the patterns and the rules don't change from whenever we would solve for an unknown variable. We apply the same skills to rearranging equations as well. It's really important to understand this skill because it helps when we're graphing linear equations or when we're solving physics and chemistry problems. So let's learn it. All right, so right here I have an example, 2x plus 5 equals 10. This is what we're used to. This isn't really rearranging an equation in the same way we're going to be today, but let's just refresh ourselves of the different patterns and rules to solving an equation, all right? So the first thing I would do is look and see if I have anything adding or subtracting my variable I'm trying to isolate. In this situation, I'm trying to isolate x. I'm trying to get it all by itself so that I can find the answer. And the answer is yes, I have something being added. I have a 5 being added to my x. Well, all I have to do is apply my opposite operation. Okay, so if I apply opposite operation, I'm going to subtract that, okay, because positive 5 minus 5 is going to give me a 0. It goes away. Now my rule of equality says that what I do to one side, I gotta do to the other side. So where I subtract the 5 here, I'm also going to subtract it from the other side, okay? So let's clean this up a little bit. 5 minus 5 is 0. It goes away. So I just have my 2x, and 10 minus 5 is 5. All right, the next thing I have to do is see if I have anything being multiplied or divided to my x. And the answer is yes, I have a 2 being multiplied to my x. So the opposite operation would say divide that 2. And what I do to one side, I have to do to the other. This is just going to leave me with x. And my answer is 5 over 2, or if you like to write your numbers in mixed form, it's 2 1/2. Now we're going to get a little bit harder. Now we have two variables in the equation. Obviously, if I have two unknowns, I can't actually solve for this, but I can use the patterns and the skills that I know from solving for x and apply it to rearranging this equation. Okay, so I'm just going to rearrange it for one of the variables, and the variable that I'm going to rearrange for is x. So I'm trying to isolate x again. Same pattern that we did when we were actually solving for x, we're going to use to rearrange for x, okay? So the first thing I want to see is anything being added or subtracted to the x? And the answer is yes, the 6y is being added to the x. So to undo it, I have to do my opposite operation of subtracting it from both sides in order to keep that equality that that equal sign represents. So I'm going to subtract that 6y from both of the sides. Okay, so 6y minus 6y, don't overthink it, that is 0. It goes away. I cannot subtract 6y from 18 because they're not like terms. So I'm just going to leave it like that, 18 minus 6y. Okay, now I say, is anything being multiplied or divided to my x? And the answer is, sure is. There's a 2 there being multiplied. My opposite operation would be division, and I got to do that to everything. Remember, multiplication and division is not a only with like terms thing. We can multiply and divide anything, whether or not it's like. Follows the pattern with fractions, with like terms. Just about everything in math follows that pattern. And so I'm going to actually divide that 2 by everything. That's going to cancel out, leaving me with my x I wanted to isolate. 2 goes into 18 9 times, and 2 goes into 6 3 times. And now I have something that I could either graph. Well, if I wanted to graph it, I would put it in terms of y, but that's a different video. I have something now that I could use for a formula and know right off the bat what x is. Let's say I have only y data. All right, so let's go ahead and back up and do this one again, but let's isolate y. All All right, so we're going to do it again, but we're going to isolate y this time, because that's how we would do it if we were graphing this linear equation. But I also threw in a negative so we can get some practice with that, okay? So there's a negative now tied to that 6y term. Now when I rearrange an equation, and this is not something you have to do, but this is my little trick if this looks confusing to you, I like to put the term that I'm trying to isolate the variable of in front. So in this case, I want to slide this negative 6y in front. Now remember from my past videos, you can rearrange the terms in an equation as long as you keep the same sign and they remain on. If one thing moves aside, everything from that side has to move the side. Okay, so we have to balance the equality. So when I rearrange this, the 6y has to remain negative, the 2x has to remain positive, and the 18 has to remain positive, which is how I did it. I just kind of changed the way it looks. All right, same pattern. Is there anything being added or subtracted to y? And the answer is yes, there sure is. That 2x is being added to the y, so I must subtract it from both sides in order to be equal. So let's look at what we have after that. All right, this is going to be a big fat 0. So I have a negative 6y. Can't do anything with these. They're not like terms, so I'm just going to write it down. All right, and then the next thing I'm going to do is I'm going to divide by a negative 6 because the negative 6 is being multiplied to the y, so I have to do the opposite operation. Now remember, like terms don't matter when I'm multiplying and dividing, so I have to do that by everything. Let's give ourselves a little more room. This is going to cancel and just leave me with the y. All right, 6 can go into 18 3 times, but I have a positive and a negative number, so it's going to be a negative 3. A negative and a negative is going to make a positive, and all I can do is reduce this fraction down to 1/3. And there's my equation. Now, if I was going to graph this, I would want to put it into y equals mx plus b form. The m is just the coefficient in front of the x, and the b is the term that's independent from the variable. It's the constant term with no variable. So when I rearrange, I have to take their signs with them, just like I did in the beginning of this problem. So if I move the 1/3 x in front of the negative 3, it has to remain positive, and the 3 has to remain negative. Now I've rearranged it in a fashion that is easier to graph on a rectangular coordinate system. Okay, in this example, we have absolutely no letters. If you know a little bit about graphing linear lines, you know this is the slope-intercept form. It's a very important equation. A lot of times we want to rearrange the standard form, which is that, okay? So a lot of times we want to take that standard form and we want to make it into this form, which is the slope-intercept form. All right, so let's get started. Okay, let's go ahead and isolate this for the b, okay? I want to get b completely by itself. All right, so it's in back. I like to have my terms in front, so I'm just going to flip-flop this entire thing before I get started. As long as the things are on the same side. So my mx plus b is still all together on one side, my y is still all together on one side, and my signs have not changed. My mx is still positive, my b is still positive, my y is still positive. I flip this around perfectly. Okay, so I'm trying to isolate this b. All right. So the mx is adding to the b. So I am going to subtract it from both sides of this equation. So it's going to look something like this. All right, this is going to cancel out, leaving me with the b, and all I have is y minus mx. and I'm done. I can't solve it any further because I don't have any numbers. I also can't solve it any further because my b is isolated. I did exactly what I came to do. All right, let's go ahead and look at another example. Okay, in this one I have a fraction. When I have fractions, there are two different ways I can go about doing this. Okay, but the first thing I need to do with both of them is put the top of this fraction in parentheses. Remember, if you've taken any of my order of operations classes on outschool.com, or you've watched any of my order of operation videos, a fraction bar, if there's operations in the numerator or denominator, that is considered do me first. It's the P part of please excuse my dear Aunt Sally or PEMDAS. So I need to put parentheses around that. The first way I'm going to solve this is I'm going to solve it using opposite operation. The next way I'm going to solve it is with a proportion, and then you can choose the method that you like the most. So I look at this parenthesis first as one thing. We're going to solve for A, and the next one we'll solve for B. All right, so I look at that parentheses first as one thing. When I'm undoing, I got to keep those parentheses together, except for I want to do distributing first. There's no distributing here. So I'm going to look at what the 2 is doing to the parentheses. It's dividing. So the way to get rid of it is to multiply both sides by that 2. That's going to cancel it out over here and give me a 2x on the left-hand side. Now I can drop those parentheses because everything is done and the fraction bar is gone. And those parentheses were tied to the fraction bar. Now I'm trying to get A by itself, so I have to look at what B is doing to it. It's adding to the A, so in order to get rid of it, I better subtract it from both sides of the equation. All right, so now I have A equals 2x minus B. I don't really like the way that looks, so I'm going to do my skills of flipping to make that look better. So now A equals 2x minus B. The B is negative. Now let's solve that for B, and let's solve it with a different way. All right, this time we are going to use what we know about proportions, about how to solve proportions. So we're going to be solving for B, okay? First thing I do, because there's that fraction, is I got to put parentheses around my operations in the fraction. Also, to make this a true proportion, I got to put a 1 under x. Now, proportions say that I can cross multiply. Okay, so I'm going to take that x times the 2 and get 2x. Then I'm going to drop down my equals and take 1 times a plus b. I got to keep that a plus b in parentheses. Okay, 1 times a is a, 1 times b is b, so I can drop the 1 and just write a plus b. All right, this time I'm solving for b, so I have to ask myself what is a doing to it. If you want to rearrange it so it's easier to see, just as long as you keep the signs the same, it's okay. All right, so now I can see that the a is adding the b, so I need to subtract it from both sides. That's going to cancel out, giving me a 0. So b equals 2x minus a, or I can flip-flop it around and say b equals 2x minus a. Awesome. Let's look at another one. All right, so this is our last example for the day. It's a equals pi r squared, and this is the area of a circle formula. Okay, so today I'd like to know what pi actually equals. What is the proportional value of pi? So we're going to be solving for that, and then we're going to do it again solving for the radius. Okay, so that we can use that square. All right, so what I would like to do first is solve for pi. Remember, we're not learning anything new. We're applying the skills we already know of algebra to this. So don't get scared by the fact that there's all these letters and weird looking things. Okay, so pi is a mathematical constant. That is just a symbol. It's just a variable. Don't worry about it. Okay, so first we're going to solve for pi. All right, so I have to ask myself, what is everything doing to pi? Well, this r squared is all one thing. The square goes to the r. The only time that I have to do anything with that is when I'm solving for r and I want everything to go away from it. But I can move the entire thing to the other side just by asking myself, what is it doing to pi? It's multiplying pi. So the opposite operation would be divide it. Okay? These cancel, and I have my pi isolated. If you don't like the way that works, just flip it around. The area divided by r squared will get me pi. All right, let's do this again, but this time let's solve for r. Okay, for this one we're solving for r squared. Remember with PEMDAS that exponents are like the last thing we do, so we're just going to save that exponent till last. Okay, let's rearrange everything else first. So what is pi doing to r? Well, pi is multiplying it. Opposite operation tells us that we are going to divide it. And the law of proportionality, the law of equality tells me that I have to do it to both sides. I have to be fair. These cancel. So a over pi equals r squared. All right, I'm going to flip that. Let's just go ahead and flip it now. You can flip it at the end if you like, whatever you like, or just keep it with the r on the right-hand side. Okay, so now I gotta get rid of that 2. So I have to ask myself, what is the 2 doing to the r? Well, it's raising the power. What's the opposite of raising the power? Well, the order of operation of raising to a power is a radical. So in order to get rid of a square, I have to take the square root. And the law of equality tells me I have to do that to both sides because I have that equal sign in there. I've made a promise that I will be fair to both sides of the equation. So if I square root this side, I have to square root this side. These two cancel each other out because they're opposite operations, leaving me with an r. And r is equal to the square root of a over pi. I hope this helped you out. If you would like me to do any other videos, please just comment and I'll try to get to them. Also, make sure you subscribe so every time I put up a new video, you will see it. And if you want to check me out in person, I have classes on Udemy and Outschool.com. And as always, go to my website, homeschoolmathmom.com, for resources, descriptions of my classes, and just my blog posts about how I homeschool my daughter in math.